Our planet, Earth, a vibrant sphere teeming with life, a delicate oasis in the vast expanse of space. But have you ever pondered how this miracle came to be? The story of Earth's formation is an epic saga, a tale of cosmic collisions and fiery beginnings. Imagine a time before our sun when the building blocks of our planet were scattered across the cosmos. Billions of years ago, our cosmic neighborhood was a chaotic nursery, a swirling cloud of gas and dust known as a solar nebula. This nebula held the seeds of our sun and our planet. Particles were drawn together by gravity. The nebula began to spin faster and faster. At its heart, temperature and pressure soared, igniting a nuclear furnace. Our sun roared to life, bathing the nebula in light. The sun's gravity drew in gas and dust, sculpting the remaining material. Within this disk, the seeds of our planet were sown. Dust grains clumped together, forming larger aggregates. This process, known as accretion, marked the first step in Earth's journey. As the young sun blazed at the center of this swirling disk, a remarkable transformation was taking place. The intense heat radiating from the sun created a distinct temperature gradient within the disk. Close to the sun, where temperatures were scorching, only the most refractory materials like metals and silicates could withstand the intense heat. Further out in the cooler reaches of the disk, volatile materials like water, ice and methane could also condense, adding to the growing mix of planetary building blocks. This temperature gradient played a crucial role in shaping the composition of the planets. In the inner solar system where Earth was forming, the intense heat favored the formation of rocky planets with metallic cores: Mercury, Venus, Earth and Mars. Further out, beyond the frost line, the abundance of ices allowed for the formation of gas giants: Jupiter, Saturn, Uranus and Neptune, behemoths, with thick atmospheres and vast systems of moons. Within the swirling disk, countless planetesimals, ranging in size from meters to kilometers, orbited the sun like miniature planets. These planetesimals, drawn together by their mutual gravity, began to collide. Some collisions were glancing blows, others were catastrophic impacts that reshaped these nascent worlds. Through this chaotic dance of collision and accretion, our planet gradually took shape. Over millions of years, Earth grew larger and larger, its gravitational pull sweeping up more and more planetesimals. And as Earth grew, so too did its gravitational influence, drawing in material from farther afield and shaping its destiny as a planet. Imagine, if you can, the early Earth. This was no blue and green oasis, but a hellish, molten world bombarded by asteroids and comets. The energy released from these constant impacts, combined with the heat generated by radioactive decay within Earth's interior, kept the planet in a largely molten state. This period, aptly named the Hadean Eon, was a time of intense heat, volcanic activity, and unimaginable upheaval. Yet, within this crucible of fire and chaos, the seeds of order were being sown. The intense heat of the early Earth caused denser materials like iron and nickel to sink towards the center, while lighter materials like silicates rose to the surface. This process of differentiation, driven by gravity, led to the formation of Earth's layered structure, a dense metallic core surrounded by a mantle of hot, viscous rock, and finally a thin, solidifying crust. As Earth cooled, a profound transformation took place. Water vapor, released from the planet's interior by volcanic outgassing, began to accumulate in the atmosphere. As the atmosphere cooled, this water vapor condensed, forming clouds and eventually raindrops. For millions of years, rain lashed the scorched earth, filling the first basins and creating the primordial oceans. This marked a pivotal moment in Earth's history, for it was within these oceans that the first stirrings of life would eventually emerge. The early solar system was chaotic and violent, and Earth bore the scars of its tumultuous upbringing. A defining event led to the formation of our moon. Scientists believe a Mars-sized object, Theia, collided with young Earth. The impact briefly melted Earth's surface and blasted debris into orbit. This debris coalesced to form our moon. The moon stabilized Earth's axial tilt and created tides, As Earth cooled, it began to assume a more familiar form. Volcanoes formed an early atmosphere rich in nitrogen, carbon dioxide and water vapor. Continents drifted, driven by plate tectonics. Tectonic plates sculpted mountains and ocean basins, reshaping Earth's surface. Over billions of years, this process shaped the continents and landscapes we know today.